In this video, we are going to talk about nanotechnology and how it can help solve the freshwater crisis. So before we start, please take some time to like this video and subscribe to our channel for future updates. Nanotechnology, often known as nanotech, is a hopeful future with a slight sci-fi appeal. It has less to do with a specific scientific subject and more to do with scale. A nanomaterial is a billionth of a meter in size, similar to how a nanosecond is a billionth of a second in time. One human hair's diameter and one sand grain's diameter are both 10,000 and 1 million times smaller, respectively, than a nanometer. Without exaggeration, one must think at an ultra-small scale and scale down their perceptions to the atomic and molecular level in order to comprehend the small science of nanotechnology. The tiniest particles of matter that can be controlled by researchers are those that are 100 nanometers in size or smaller. Sustainable nanotechnology has significantly aided in supplying humanity with clean water. In this review, we discuss the urgent need for solutions afforded by nanotechnology to increase access to clean water, as well as the significant inequalities in guaranteeing their implementation. By extending the idea of clean, affordable, and sustainable water to the ecosystem as a whole, we point out that cities may live and breathe comfortably by using such technology. Sustainability in clean water can be achieved by comprehending the major environmental issues facing the world and investigating potential solutions from new nanotechnologies. Nanotechnology-based water filtration makes use of microscopic components like carbon nanotubes and alumina fibers. Additionally, it makes use of nanoporous zeolite filtration membranes, nanocatalysts, and magnetic nanoparticles. For the analytical identification of pollutants in water samples, nanosensors based on palladium nanoparticles or titanium oxide nanowires are used. The pollutants that nanotechnology can address depend on the level of water purification to which the approach is used. It can be used to get rid of infections, bacteria, charged particles, and chemical effluents. They clarify that employing nanotechnology, hazardous trace elements like arsenic and viscous liquid contaminants like oil can also be eliminated. The key benefits of employing nanofilters over conventional systems include the fact that less pressure is needed to move water past the filter, are more effective, and have an extraordinarily huge surface area, making them easier to clean by backflushing. For instance, membranes made of carbon nanotubes are capable of filtering out practically all types of water impurities, including turbidity, oil, bacteria, viruses, and organic impurities. Carbon nanotubes have been found to have an equal or faster flow rate as bigger pores, while having pores that are substantially smaller. This could be because the inside of the nanotubes is smooth. More quickly than traditional filters, nanofibrous alumina filters and other nanofiber materials also remove negatively charged pollutants like bacteria, viruses, and organic and inorganic colloids. Although the present generation of nanofilters may be quite basic, it is anticipated that subsequent iterations of water treatment devices based on nanotechnology would take advantage of the features of novel nanoscale materials. Despite the positive news, there are concerns associated with using nanotechnology for water purification. Some people are calling for greater research to identify these risks to human health and the environment. The fact that nanoparticles' increased reactivity also increases their toxicity is a major cause for concern. Furthermore, because nanoparticles are so small and challenging to contain, there is a risk that they will escape into the environment and endanger aquatic life. Nanomaterials represent an unknown risk whether handled in the treatment facility or ingested in treated water. Nanotechnology, according to Ben, offers a way to enhance water quality through treatment and remediation. However, there are also worries that nanoparticles may end up in water systems as a result of the usage of nanotechnology. The researchers observed that the general public and activist groups have expressed worry about a number of fundamental characteristics of nanotechnology. Since nanoparticles have a much higher surface area to volume ratio than bulk materials, they may be more reactive and result in interactions with biological surfaces that have not yet been recognized or tested. They admit that the risks associated with nanomaterials may not be the same as the risks associated with the bulk versions of the same materials. Nanotechnology-based water filtration hasn't yet caused any issues with human health or the environment, but the team agrees with others that further study is needed to understand how nanoparticles interact with living things. Do you think nanotechnology is a sustainable means for water filtration? Let us know what you think in the comments section below. If you liked this video, hit the like button and send us your thoughts and comments in the comments section below. Be sure to subscribe for more. Thanks for